Hello guys, welcome to my channel. Let me introduce myself first. My name is Annawal and I am currently in third year in Triple IT Sonipat doing BTech in CSC. So yeah, I have changed my position like location. Reason behind this, I think in my previous videos there was a little bit visibility issues or no proper lights at all. So yeah, I have changed my position location or without any much further delays, let's start with the question. The question is your problem decode forces. I think, wait a second. Yeah, from code forces that is running miles. And let's start reading the question. There is a state with n sites, with site number I being I miles from the beginning of the state. Okay, so at the ith index, it is about I miles from the beginning of the street. A total of there are n sites. So site I has a beauty BI, and what we are doing is we are starting jogging. That is, we are doing start from the L miles, and end it at R miles from the beginning of the street. Okay. By the time you run, you will see sites you run by, including sites at L and R miles from the street start. When you are interested in the three most beautiful sites along your jogging, but every mile you run, you get more and more tired. Okay, so let's choose some L and R such that there are at least three sites you run by, and the sum of beauties of the three most beautiful sites, and blah blah. You do okay, and the three. Let's see this. Okay, so the sum of beautiful three most beautiful sites minus the distance in miles that we have run so far. And they have given us the formula too, like b of I1 plus b of I2 plus b of I3 minus R minus L should be maximum possible. So we have to find out the maximum beauty that we can achieve so far. So what is the input that we have given? That is number of test cases, that is about 10 to the 5 and single integer n, and then all those beauties of sites. Okay, so it is granted at, okay, so we have to maximize our the answer. That is b of I1 plus b of I2 plus b of I3 minus R minus L. So what is the question saying so far? We have some insights, and in those insights, we start with some site. We start from some site, and we end up start from some site. That is, let's suppose b of I1 or ith index. We start, and then we ended up some jth index, and in between of those jogging we have to choose minimum we have to choose three sites. Then that three sites we have that chosen that may and may not include L and R, and the output that we have to give, that is those three sites beauties minus R minus L, that is jth minus ith index, that is distance so far. Okay, so let us choose the test case next. And the algorithm. Like I want to tell you that such type of question, like they have given some, there is some algorithm that we have created, or they have given us the algorithm. Try to get some insights from them. Uh, like here, B of I1 plus B of I2 plus B of I3 minus R minus L. Like these types of formulas, or they have given formula. Try to get some insight. Try to think from here. Try to think. Like we can go with the brute force. I will tell you brute force first. I think so. Like how can we think? So the brute force that comes out to be like order of n cube. To iterate three times and then choosing from all of them, and then uh, choosing three of them, and then subtract r minus l. That's it. And we can do this in order of n squared too. Like for loop, like what we can do is we choose, let's suppose this one, and at jth index we have chosen two, and then find out the maximum so far, and then that's it. Like we have done in order of n squared too. But order of n cube and order of n square will work for this question, or it will give us TLE. Since so since we have given constraints, that is n should be less than total would be less than equal to 10 to the power 5 lesser than. So if we do order of n cube, that will go around 10 to the power 15, and order of square, that will go around 10 to the power 10. So we can't go with it, will give us TLE. Since the code to be run in such platforms, or the better way to run such problems, or like what I'm saying is 10 to the power 8. We at most 10 to the power 8. So we can go with order of n log n of n log n, and sorry, about 10. So first of all, let me tell you, I have also seen the editorial and the video of this question, because I also couldn't solve. But there is something that I have also thinking about that, but I didn't get now. But I will tell you later what I have think and where I am facing some issues. So if you can solve those issues, if someone is good at CP and if he or she can solve these issues, it would be helpful for me too, and you also. So without any much, let's start with that. So BO51 plus BO52 plus BO53 minus R minus L. Like what I have seen so far, like in many questions that gives us such type of equations. So the better insight that we can get is to solve such equations first, to get some insights from here. So what insight that we can get? Like B of I1 is what? Like first of all, let me tell you that if we have A1, A2, A3, A4, and then A5, and then A6. If we have to choose A2 to A5, then what we will choose to get the maximum beauty of size. That is, rather than choosing L at A1 or wait, L at A1 or and A6 as R, it's better to choose A5 as R, that we are choosing. That in between we are choosing some beauties. Okay, that is A2 and A5. Choose this as R, L. So so it's the main observation. Like don't choose a index that is lesser than that for L, and same with R. If we are choosing two beauties, like we are fixed that we have to choose A2 and A5, and in between we can choose any maximum that we have solved for, that we have done for order of n square. So that the first main observation. Then how so can we solve like B of I1 and then B of I3? We know that R is fixed to this and L is fixed to B of I1. Then B of I2 we have to choose maximum out of that. So as I have already said earlier that B of I mean like we need to get insights from here if we can get. So B of I1 is related to L. So that we have solved, and P of I2 is the thing we don't know right now. And B of I3 is related to R. So can you think like it's an independent entity? Like it depends on its index, like plus L, that is the index at which that side beauty is present. So it's depend on its index, like okay. And same with B of I3. It depends on its index that we have to minus. So these two both identities are like dependent on their index, not any other values. So we can think, okay, so yeah, you are right. Like they are dependent on its index. So which one is not dependent? Like we have also seen, is as clear that we have done in order of n square. What is not we don't know about? That is this, the maximum part that we can get. So what if we can just fix up this and we already pre-compute our the health part and the arts part. I mean the whole array first of all, pre-compute. That is prefix and suffix. I will tell you why prefix and suffix. Okay. So what we would do to fix P of I2, we would what we would do to fix P of I2, we would fix it, and then we will find out the maximum. Now let's move to the core part. Then I will explain like you get the overall what we are doing. So first of all, we have taken test cases, and then um, let me wait a second. Yeah, here it is. So what we have done is to choose like take an input n and then create a vector v of n plus 2 since uh, the zeroth index and n plus 1th index we are choosing like they are just a temporary basis. They will help in our future. I will tell you why. And then vector of LL, that is long because the contents here may can exceed our limits for integer overflow. Integer overflow will happen. And then maximum suffix of n plus 1 is equal to int minimum. I will tell you with the test case. Okay. So what we are doing, like in text, that is v of I equal to x, that is input taking the value inside the vector. And then what we are doing is to find out the maximum value so far, prefix of so far. I will do this with the test case. Okay. Since we know that a of I, b of I plus l, we have to find out. So if I am at this index, like the second index, that is the value is 4, what I would seek for, like the maximum so far at here and maximum so far at here, like the previous and the future one. So what is the maximum so far I can get? That is b of I1 plus L and b of I3 minus R. If we do, then what is the maximum I can get? So this we need to pre-compute as you already said. So that's why we use prefix. So 4 and then we just store it up. Then same with suffix. We have introduced suffix since we need to find out the so far the maximum value at here at this index. That's why we have choose prefix and suffix. And why I have chosen n plus 2, you can choose n, but you have to be much precaution about like it should not be exceed our size of like n or zero thing like minus 1 or something like that. It's just a precaution like 0, 5, and 1, like something like that. Then if we do the maximum, so we like, let me explain here. Like if we do the maximum prefix, so the previous maximum prefix and then v of I plus I. That's why I've chosen like zeroth index should be 0. So it doesn't matter like I minus 1 and that's why. It doesn't exceed like, sorry, it doesn't go minus 1. It doesn't break our code. Same with suffix. So what I have done is maximum suffix of int medium. Why I have done this? The reason behind this I have done like because the last index is let's suppose j like I and the value at here is 2 and the ith index is 3. It can be minus 1 and the maximum value that 0 and minus 1 is 0. So like giving the answer like it's not restoring the actual answer. But when it comes to the maximum prefix of this, we are not doing any into minimum. You can like if you get the if you can think like more easier way, you can go with that. I think like this way to we get more precautions to for more precautions and to not break my code. So let me explain for the maximum prefix because the ith index is 1 and the maximum value it can at there it so minimum value can there it be 0. So 0 and 0 maximum would also be 0. So that's why I've done that. So it doesn't like make our that value that to be wrong actually. So we have stored maximum suffix and maximum prefix, and then we just then calculate. That's it. And yeah, one thing you should note that we are starting from I equal to 2 to n minus 1. The reason behind this, if we choose the first index, like I equal to 1, then we are just ensuring ourselves that we have to choose only suffix part at and that would be only one value. So there the total value that we are choosing only two. We have to choose at we have to choose three beauty sites, not two actually. So we are going from I equal to 2 to n minus 1. So that's how this question will be solved up. And yeah, I should come about my solution part. Like not solution part, what I was thinking, but I don't know why. How can I solve it furthermore? I would think it more. And if I think, then I will share with you too. So let us suppose we are with 51423. What I was actually thinking first? Like B of I1 plus B of I2 plus B of I3 minus minus N. I was also thought about order of n square. Then I would thinking like how can we find out the maximum? Like we have to move another order of n. That was I was also thinking. Then I got that. So forget about it. So what we can do is B of I1 distance from B of I2. Like B of I2, let's suppose that let me explain it more clearly. Like if we are at this zeroth index, then we need to choose the second site that is maximum for the zeroth index respectively. Like for the fifth for the zeroth index, what is the maximum so far for it if we travel? It would be one minus one that is zero, and four minus two that is two, two minus three that is minus one, and minus one. So two is being maximum for it, second index. So it would be it says that to get the maximum beauty from my side, if you are at my side, then you should visit to this site actually. It would give the maximum also if I would recommend. It says zeroth index says. So for fifth we would travel to four to get the maximum beauty. Now what about four? If we are fourth index, then we just not we just what we will do is to find out what is the maximum it would give us. Like the same that we have done with the zeroth index. Like for that third index, it would be minus one. Wait, it would be like for one and one. So it's saying like you can visit any of them. So we would choose any of one of them, and here it our answer will be five plus two seven, and then plus one eight. Yes, I think one thing I've done wrong. Wait a second, just wait a second. Wait a second. Second, is because I already checked. I was right at that time. Wait a second. Yeah. So like we know, okay. So we know about this, but you would say like we you need to pre-compute and pre-compute again and again. No, that's not. Like for the zeroth index, we just store the values like 0, 2, minus 1, and minus 1. Then when we move to the first index, all of them just come closer. That is, we would do plus 1. And these all values would be put inside set. And would just choose the highest value so far and then just uh, plus 1. Then we just store, like, let me clarify it more. Like we just store in the set. And then when we move to the first index, then we what we would do what we would do is to just first of all we have to remove this zero from here. First of all, we have to remove that the ith index that we have to remove from the set and then get the maximum value that is 2 here. And then we will store in a map that links that the zeroth index is linked with third index and its value is 2. And its value is 2. That's how we will do. And yeah, I think you got it more rightly, or I will just at last I will conclude it more properly. So wait a second, like I will do it more properly. I think I should explain it more properly. So let us suppose 5, 1, 4, 2, and 3. What I have done is to store like you can store it pair, sorry, wait, set of pair of int and int. Okay. So first of all, what I am doing is to just find out the distance of zeroth index with all others. It would be 0, it would be 2, it would be -1, and it will be -1. And then just store in the set what it will be look like 2 and then 0 and then -1 and then -1. So wait, it's a set of integer only of pair of it. I forget. So the second one is at second index and the 0 1 is at first index, and your multi-set we will use multi-set. It would be at third and it would be at fourth. Set or multi-set doesn't matter at here because index are partitioning at all, are making difference between them. So after storing this, when we move to the what I would do, like for the zeroth index, what I will do, like I would just make and vector and at pair of int comma int of v. Let us suppose we name it v, and that would be n. And what I will do, v of 0 will be equal to 2 comma 2. Here 2 represent your the value and 2 represent your index. Okay. So for the zeroth index, we have ensured that the maximum distance it can be from the second set of the beauty will result as 2. Then what would happen if we move further? Like for I equal to 1. Since we are moving more forward, then the value will be +1. I will tell you. And here that doesn't matter if you're thinking like we need to change the set, we need to change the set. It doesn't matter at all. The reason behind it, when we come closer, the all other values become +1. And the set value didn't change. The set value will change, but the maximity would never be changed at all. Like if second index is maximum, then it will be maximum. If the third index is maximum, then it will be maximum. I will explain it more like at here. If we at ith index, that is 1, 4, 2, and 3. Then if we are at I equal to 1, then what would be the values so far? 3 and 1 and 0 and 2 and 0 and 3. What has the maximity doesn't change at all. But the value changes, but maximity doesn't change at all. So that doesn't matter if you are moving forward. So that's why we will get always the maximum part of it. So here, what we will do further is that we find out the maximum part. That is 3 of 1. Like that is this. So the index v of 1 will be equal to it points us to 2. It points us to 2. And its value that is given at here +1 we will do. Since we are getting closer. So we will store for all of the contents of the array. Then we would move like for I int I equal to 0 and wait. I should be less than n. Uh, Typing errors, and then we just store the maximum and v of I dot first. Like we would choose the two values. That is this points 0 point to first index and first index point to second index. That will give us the maximum value. That is the three sides. We would now like finding out the maximum value by iterating throughout all of this. So this is how we can solve this problem. I think so. Like yeah, we can solve. But the issues comes when I was solving like the issues when what will come. The issues comes when there is the same value so far. What I mean by that, like we didn't have a perfect choice. A perfect choice here means like for the ith index, there are others index, other index too that have the same value so far if we just check the maximum value that it would give if we travel. Like for the ith index, the I plus 1 gives us 2, I plus 3 gives us 2, I plus 4 gives us 2, and maybe 3, and then again 2. Then we need to store into some vector, then we need to store into some vector, and then we have to iterate all of the values then. And then that will cost us around order of n square again. Why? 1, 2, maybe 3, and then 4, and then 5. For the first index, what is the value we can store? 1, 1, 1, 1, 1. Then we need to store all of them in vector and then link up to what we have done so far. It then we are just doing is moving again and again, and it would be pushed around order of n square. So that why I don't know like what should I do further to maybe to solve this. So if you have any ideas related to this, so put out in that comment. And if I quote up, like I will try it again and again. Like if I get up some idea, then again I will make a video on this. And yeah, so I hope you get it. So that's from my side. Bye.